Hey guys, welcome to the last day before Easter break. So, heading into a break that we all deserve, we're just going to do a quick little grade 10 review so that when we come back after Easter, we can kind of hit the ground running. So, the next outcome we're doing is radicals. So, in grade 10, you were exposed to radicals. Remember that a radical is simply a root that does not calculate nicely. So, if I have like the square root of 25, that gives me 5, but we're specifically looking at things that don't have perfect square roots, like 27 or 5 or something like that. So it's a way of using exact answers instead of rounding when the number is irrational. Okay, so we've looked at this already, like when we were doing quadratic formula, we were expressing them in simplest radical form. So it's similar to when you use a fraction. So for example, if I have 2/7, that's a rational, it's an exact rational number. If I want to make the decimal approximation, I just take 2 divided by 7 on my calculator, and it gives me this. And we've talked about that when we're solving equations or doing exact math, we want to use exact values. If we're doing word problems or applicable real life things, we'll often use decimal approximations. Okay, so if I have an exact radical, that's root 5, the decimal approximation would be 2.2361. I can put that into my calculator. Remember, an irrational number is one I always say, like, if you're irrational, you're kind of out of control. If you look at the decimal number, when you put in root 5, for example, it's a non-repeating, never-ending decimal that seems to have no pattern and you never really know what's coming next. So it's called an irrational number. Okay, just a couple of definitions. So when I have a radical, so you can have a coefficient of a radical, just like you can have a coefficient of a variable expression like 3x. There is the radical symbol, which is like the little square root sign. But we're going to be dealing with not just square roots, but also cube roots, fourth roots, fifth roots. So this little guy right here is called the index. It's telling you how many of the things need to multiply to give you the answer inside. And then we have the radicand, which is inside. Okay, so radicals can be expressed as a mixed radical, 2 root 3, or an entire radical, root 12. We're going to look at going back and forth between those two forms. Now, it's super important that you understand that you have to show all work in this outcome in order to get credit for things, because lots of us have those fancy calculators that will do the work for us. So if I was to punch in root 50, for example, in my calculator, it will display 5 root 2. But if you don't show me the work about how you got there, you're going to get no marks, okay? So I'm going to go through how you show that work. So basically, what you do is you're going to use the perfect square list that I had you create in the perfect cube list. So I had you on a cue card give the first 20 perfect squares and the first, I don't know, I can't remember what I told you, to use 7 or 8 or 10 perfect cubes. So those are numbers that you kind of want to recognize. So basically, when we're breaking up these entire radicals into mixed radicals, we want to find numbers on that list that do divide into 50. Okay, now we want to start with the largest of those numbers. So what I always suggest is you go to the perfect squares where 50 would fall between. So for example, if you're looking at your perfect square list, you will see that you have 49 and then you'll have 64. So 50 falls in between there. So you want to start there so that you can get there in one step. Okay, so we're going to break 50 into things that have perfect squares. So I would be looking here and then I go back down from there until I find a number that divides by 50 evenly. So this one can be broken to 25 and 2. Okay, so you can write it like that. Some people also like to write it as two separate radicals. You do whichever one you prefer. I tend to do the first one. Okay, and then anything that can be square rooted is square rooted. So the square root of 25 is 5 root 2. Okay, so if you have a calculator that does the work for you, I mean, by all means use it to check, but you have to show that breaking it down to 25 and 2, and then it becomes 5 root 2. Also make sure that you are aware that there is still a square root symbol here because the operation has not been performed. You can't just drop the square root symbol and then bring it back at the end. You need to make sure that you use it appropriately throughout your entire question. Okay, 48. So what can I break 48 into that has a perfect square root? So it can be 16 and 3. And the square root of 16, when it comes out, it will be 4. And this 3 is stuck inside of there. So root 48 is the same as 4 root 3. Okay, for the cube root of 40, so now I'm looking at things on my perfect cube list that will divide into 40. So I can break the cube root of 40 to 8 times 5, and the cube root of 8 is 2 So I have 2 cube root 5. Now be careful how you are writing this. You have to make sure that your radical symbol goes like all the way to the end of your number. You have to make sure that your index is a tiny little number on here. Over here, there's no index here. That's an implied 2. Okay, so like there's an invisible 2 there because it's a square root symbol. So if there's nothing there, it's a 2. Otherwise, it's a little guy. It's on the tail of the radical. The cube root of negative 54. So we can indeed cube root negative numbers. We can't square root negative numbers, but we can cube root negative numbers. And when you're breaking this, you always want to bring the negative out. Okay, so the number that does have a perfect cube, we're going to keep the negative with that. So it's going to be negative 27 times 2. And the cube root of negative 7 is negative 3. And I'm left with a cube root of 2 stuck inside the bracket. Okay, so just please be careful about how you're writing that. Sizing matters. So these two are the same size, the 3 and the 2, and the cube root index is little and tiny. Okay, so now if I want to go the opposite way and I want to write it as an entire radical, so what that means is that I want to actually put the 3 back inside of there. So what you will do is you will look at the little index. So in this case, it's an invisible little 2. So that means when I want to put it back inside, I'm going to have to square it. And then there's also a 5 in there. So 3 squared is 9, times 5 is 45. So 3 root 5 is the same as root 45. Okay, 7 root 2. So if I want to put that 7 back inside of there, because this is a square root, I'm going to square it when it goes in. So it'll be 49 times 2, which is 98. Okay, and then 3 cube root 2. So because this one has a cube root, I'm going to have to cube it when I put it back in. So I'll have the cube root of 3 cubed times 2. So that is going to be 54. Okay, so that's my answer there. Okay, so now if I want to place radicals in order from smallest to largest, like honestly, you could make them all into entire radicals or in that, like see which number is the biggest. So you could technically, there's a few different strategies. You could definitely put everything inside of the radicals, make them all as entire radicals, and then see which one is the biggest. Personally, honestly, I would just take them all and make them into decimals and then arrange them. You just have to make sure that because if they're given as radicals, you can think in decimals, but you need to make sure that you order them as radicals when it goes back. Okay, so what I want you to do is pause this video and I want you to turn each of these numbers into their decimal forms, go to like 2 decimal places, just in case there are some that are close, and then we'll order them. Okay, so pause the video now. Okay, so here are the numbers in decimal form. So now we want to order them from smallest to largest, but we're going to have to write them as their radicals. So the very first one, smallest number, is the cube root of 8. So that one will come first. And then it looks like it'll be the 2 root 3, and then root 40, and then 3 root 5, and then root 50, and finally 4 root 7. Okay, so you can think of them in decimals. You just have to make sure you express your answers the same way that they're given. Okay, now we want to look at writing entire mixed radicals using algebraic radicals. So not just numerical, but algebraic. So kind of the same idea. In order to be able to take the square root of something, the exponent has to be divisible by the index. Okay, so this is an implied little 2 here. So I need to break this into things that are divisible by 2. So you can see that my x to the power of 4 is fine, but my y to the 5 is not divisible by 2. So I want to go to the closest thing to 5 that is divisible by 2. So this is the same as y to the 4th times y to the 1. Okay, so remember that when we are multiplying exponents, we add them. So, and then z, okay? So the things that have perfect squares are those that are divisible by the index. So those two things are going to come out, and when they come out, you're going to divide the exponent by the index. So there's that implied little 2 there. So it'll become x to the 4 divided by 2, which is x to the 2, and then y to the 2, and I have a y and a z that remain inside. Okay? You can have a combination of numbers and letters, it's this, then you've got to really kind of be on your toes. So we're looking at something that will divide into 20 that has a perfect square root. So I can break that to 4 times 5, a to the 3. So 3 is not divisible by 2, so I'm going to break that to a to the 2 times a to the 1, b to the 2, b to the 1, and c to the 2. Okay, make sure those square root signs trail all the way to the end. Don't leave them short. And then anything that can come out is going to come out. So the 4 can come out, the a to the 2, b to the 2, and c to the 2. So the square root of 4 is 2. The square root of a squared is a. The square root of b squared is b. The square root of c squared is c. And I'm going to leave the other things trapped inside of there. I will have 5ab. Okay, here's a cube root. So in this case, I want to break it to things that are perfect cubes. And for my exponents, they need to be things that are divisible by 3 this time instead of by 2. So this will become 8 times 2, x to the 3 times x to the 2. 12 is already divisible by 3, so I will leave it. And then z to the 6, z to the 2. Okay, so the things that can be cube rooted are the things that have exponents divisible by 3 or have perfect cube roots. So this will become 2x, y to the 4th, z to the 2, and then locked under my cube root symbol are going to be 2x squared, z squared. Okay, so you have to be super careful when you're writing because like there's a squared here and then the cube root, you just kind of keep everything normal and neat. It's important that you are neat when you're doing these kinds of questions. Okay, now we're going to go from mixed to entire. So the same idea. If I want to put these things back underneath, I'm going to have to square them. So it's going to be 12xy squared times xy. So this will become 144x squared y squared times xy. Then put together my x's and my y's. Oopsie, that should be a y squared. This should be a y cubed. 144x cubed, y cubed. Okay, 3m squared n squared. If I want to put that underneath here because this is a square root, so I'm going to square this. So I square 3, which is 9, m to the 4, n to the 4, 5m, and then put everything together. So this will be 45, m to the 5, n to the 4. Okay, and our last one is a cube root. So when I put my numbers back underneath, I'm going to have to cube them. So this will become 2 cubed is 8, x cubed, y to the 6th times 4x, y squared. Putting everything together, I will have 32x to the 4th, y to the 8th. Okay, so that is dealing with letters. You need to remember your exponent rules from grade 9. Now, another quick thing to remember is that if you don't really remember this from last year, that when we have a fractional exponent, that's actually a radical. Okay, so the denominator goes in denotch. So I can write x to the 2/3 as the cube root of x squared, or I can also square the x first and then apply the cube root. So we're going to write a few of these as fractional exponents in radical form. So 27 to the negative 1/3. So first of all, remembering our negative fraction rules from grade 9 and 10, this becomes 27 to the 1/3 in the denominator of the fraction. And then this becomes denominator in denotch to the power of 1. So the cube root of 27 is 3, and 3 to the power of 1 is 3. So this is equal to 1/3. Okay, if I have 12x to the 4th, y to the 5th to the power of 3/2, so this is going to be a square root of 12x to the 4th, y to the 5th, all to the power of 3. So I'm actually going to apply that power of 3 first because I might as well, instead of having to do it again later. So this is going to be 1,728 x to the 12, y to the 5th. And then I'm going to simplify this. So I'm going to need to break 1,728 into anything that has a perfect square. Okay, so this guy breaks down to 576 times 3. Remember, if you can't think of like the biggest one first, then you just start smaller and you might have to go with multiple steps. And then I want to break my letters into things that are divisible by 2, because this is a square root, so x to the 12th is fine. Y to the 4th, y to the 1. I need to extend that a little bit to include all my numbers. And then the square root of 576 is 24. X to the 6, y squared, and I will be leaving my 3y on the inside. Okay, one last one to do here. So I've got 27 m squared and mn squared to the power of 5/3. So that is going to be the cube root of 27 mn squared to the power of 5. So 27 to the power of 5 is something very large. In fact, actually, I think what I might do on this one is apply the power of 5 after, just so I don't have such huge numbers. So I'm going to get rid of this. I'm going to do this first, and then I will apply the power of 5. Okay, so then that means that my 3 can come out. So this will become 3, and then I'll have this mn squared to the power of 5. Okay, so now I have to go 3 to the power of 5 is 243, so that's on the outside. And then this power of 5 here, I'm going to have to apply that to the guys on the inside. So I have m to the 5, n to the 10. And now I can break those down. So that was a little trick that I did just to avoid the huge number of 27 to the power of 5. So this will be m3, m to the 2, n to the 9, n to the 1. Sorry, that should have been m's at the beginning there. So I've got 243 m, n to the 3, and I leave a cube root of m squared m inside of there. Okay, so you can go ahead and practice. There are several questions for you to work through. Just make sure that you, on those numerical ones, you have to show me your factors in order to get full credit. All right.